And today we are going to learn about weather prediction or weather forecasting using satellite communication. It's me, Snushngan Papang. Let's begin. In everyday life, we all depend on weather forecasts, and this is one of them. This is one of the weather forecasts which I have taken from my from my phone, and we all see today, tomorrow, the day after tomorrow, in a couple of days it may be sunny or storm or cloud or snow and so on. Now before that, let us begin to know what you mean by forecast or forecasting. What do you mean by forecasting or forecast? The term forecast means to predict the future, and weather forecasters try and predict the weather in the future. Remember, in the future, and either the next day or the next couples of days. And this is one of the weather forecasts I've taken today. It's supposed to be 29 hot and then cloudy tomorrow, the next couple of days. Let us move ahead and continue. What are the procedures of weather forecasting? What are the procedure or steps that are involved in this weather prediction using satellite communication? And the first is data collection, observation, and data transmission, and many others. Now let us go one by one into detailed. The first one is data collection. Collection of meteorological data from various sources, including ground-based weather station, ocean radar system, and weather balloons. Then the second one is satellite observations. It should observe after collect the data, how it is, whether hot or sunny or rainy and so on. Satellite play a crucial role in weather prediction. Remember, without satellite, we cannot have weather prediction. And they provide data on various atmospheric parameters, including temperature, humidity, cloud cover, and wind patterns. These observations are made using instruments like radiometers, spectrometers, and scatterometers. Now let us move ahead. The data transmission. After data collection, we have the satellite observation. Then we move to the data transmission. The data collected by satellite is then transmitted to Earth via satellite communication links, and this data is sent to ground station, which receive and process the information. And after data transmission, we have the data processing, where it processes the data. The received data from data transmission and data collection is processed and analyzed to create a comprehensive view of the Earth's atmosphere. This involves data assimilation, where the satellite data is integrated with other observational data to create a consistent and accurate representation of the current of the atmosphere. Now let us move ahead and learn about more of the steps. Like one of them is the numerical weather models. Meteorologists use numerical weather models to simulate the Earth's atmosphere and make prediction about future weather conditions. These models are based on complex mathematical equations that describe atmospheric processes. They require extensive computing power and input from the collected satellite data. Then we move on to model initialization. These are satellite data along with other observational data which you have seen earlier. They are used to initialize the numerical weather models, some models or some tools. This means that setting the initial conditions for the model to simulate the current state of the atmosphere, And we move on to the model integration, where integrate whole thing. This numerical weather model is run forward in time to predict future weather conditions. The model uses the laws of physics to simulate the behavior of the atmosphere over time. And we move on to the next, that is forecast output. We should have an output, then only we can see the output in our mobiles, in our TVs and so on. And meteorologists use the output for what? from the numerical weather model to generate the weather forecast. And these forecasts can include prediction from temperature, precipitation, wind speed and direction, cloud cover, and other parameters, other meteorological parameters. Next, after all those models and all those stuff, we need verification of the relation. It should be verified and it should be valid and up to date, right? So we go to verification and validation. Weather forecasts are compared to actual weather condition to assess the accuracy of the prediction. There should be some accuracy, then only we'll believe it, right? So this verification process helps meteorologists refine their models and improves forecasting techniques. In all those stuff with data transfusion, data collection, data processing, then weather miracle models, integration models, then at the end we need verification and validation. And after verification and validation, what do we go? We need communication, which is one of the main things. Without communication between the maybe the tools or the sensors and the actuators, and between the output which we get from mobiles and all, there should be a communication. Once the weather forecasts are generated, they are communicated to the public and various stakeholders through various channels, including televisions, radio, websites, mobile apps which we see in our mobile, and emergency alert system which we have all known from the web, from our government and so on, during tsunami, during hurricanes and cyclones. And satellite communication is also used to disseminate weather information to remote areas, even remote areas, so it can go because of satellite is on top, so there can be. Then the last we can see in this step is monitoring and updates, which is very also important and steps in this in this weather satellite prediction using communication, because weather prediction are continuously updated as new data becomes available. And satellite play a key role in providing real-time observations, real times, and to forward to refine and update forecasts as needed. Now let us move ahead. And the last thing, decision making. Who make the decision? It is a government agency, emergency responders, and business use weather forecast to make informed decision regarding public safety, transportation, agriculture, and so on. And the accuracy of weather prediction depends on the quality and quantity of data collected from satellite we have seen earlier, as well as the sophistication of numerical weather models and the expertise of meteorologists in interpreting the data and model output. It should be the interpreting of by the meteorologists, it should be correct, so that we get a correct output of the models and the weather forecasting. And advance in satellite technology and data assimilation technique have significantly improved the accuracy of weather forecasts in recent years, and many more research have going on, especially due to floods and then cyclones, so that we can get afar and save so many people and so on. A brief information about weather forecasting center and the whole of the world. We have seen here observatories and meteorological station. We have 9,500, and ship-based observation center we have 7,400 plus, and radar station we have 600 plus. Upper air weather station, that is in the air, we have 2,300 plus. And there are three major international centers: Washington DC, Moscow, and Melbourne. Next, we move on to the next topic, that is the tools in weather forecasting. What are the tools we use in weather forecasting? The first tool we use is the radiosondes or radiosondes. I don't know how it is pronounced. You let me know in the comment section below. So this is the radiosondes. It looks like a balloon, but there are some transmitter working behind it. And what it is, this is actually an instrument that is carried aloft by a balloon to send back information on atmospheric temperature, pressure, and humidity by means a small radio transmitter. This we can see a small radio transmitter. Then let us move on. The next is the weather satellites. And these are the weather satellite connected all around the world, the globe, with different tools of it. And what is it? Let us learn about it. The most significant device is weather satellite of different kinds attached with different types of sensor for specific purposes and having varying orbital paths around the Earth. That means the sensor which are the inputs, they are for specific purposes they will act. And the first weather satellite named as TIROS 1 was launched in 1960. And the sensors which are attached with satellites send back to the image of cloud to Earth center. So now we continue with weather satellite, but it's on the basic of orbital parts. And this is the geosynchronous satellites. What is geosynchronous satellites? The some rate of movement around the Earth as that of the rational speed of the Earth is the same rate. These are fixed at altitude of 35,786 kilometers from the sea level, and these are called high altitude satellites. They are called high altitude satellites, and it provides scan pictures of large area, and they have imaging sensor instrument that provides thermal variation of the atmosphere, moisture, and so on. And the best example I would say is the ATS, which is application technology satellite, and the GOES, which is the stationary operational environmental satellite. They are the best example of weather satellite on the basic of orbital satellite or geosynchronous satellites. And we move on. This is the GOES and this is the ATS. And now what is the GOES? As I said, it is a geostationary operational environmental satellite. What is its function? Its main function is it provides continuous imagery and data on atmospheric conditions and space weather. And what about this ATS, which is application technology is satellite? This also is one of the communication satellite for weather observation and investigation. And let us move on to the polar orbiting satellite. What is this polar orbiting satellite? Actually, this communication satellite, which is used in focusing satellite. And let us learn its function. These are positioned after they are launching by the rocket at altitude ranging from 800 to 1500 kilometers. They are also known as low latitude satellites. And they are having sounding sensor naming as advanced very high resolution radiometer or AVHRR. And the best example I would say is TIROS and NOAA. What is TIROS and NOAA? Now this is the NOAA and this is the TIROS. And what is this NOAA? It is the full form is National Oceanic Atmospheric Administration. Is similar to that of NASA. And what is its function? The first thing it does is it provides data from space forward to monitor the Earth and to analyze coastal waters. And also it predict what? It predict and track tropical storms and hurricanes and tsunamis, which are very helpful for us, especially those are living in near the sea shore and near the bay, like the Bay of Bengal in India. And this is the TIROS. The full form is a television infrared observation satellite program. What its function is similar to an OAA, and it provides accurate weather forecast based on data gathered from the space. So we shall move ahead with the radar. And what is this radar? The radar. So actually these are the tools to obtain detailed information about clouds and storm, mainly cyclone, tornadoes, hurricanes, and tsunamis, as we said in India. And how it is work? It works as there is a transmitter, and from the transmitter is received it received the clouds and the rain, and from that it returns back to the radar, and that how the radar works. And let us move ahead and to say now we have come to with the tools, the process, and in summary what we can say about this weather forecastings using satellite communication. With the advancement of technology, weather forecasting has developed its level best, but there is yet to develop as far as nature is so unpredictable. Natural calamity and weather disturbances causing devastating destruction surprisingly. And to save our Mother Earth, scientists and meteorologists are also advancing their knowledge about weather forecasting, and many researchers are going on, especially to help people during the floods, to predict the floods, how serious it is, how bad it is, how small it is. And this is one of the major issue we are facing now, and is worth studying and worth research, and you can do a lot of project with it. And I hope you have got a lot from it. And thank you so much for listening to me, and see you in the next episode. Thank you.